Hi there guys, welcome to this video. In this video I've got a really interesting problem for us to look at from mathematics, and the problem that I've selected is from this book, which I've used in a few of my other videos, Challenging Problems in Algebra by Posamentier and Salkind. And the problem that I've chosen is from chapter 12, and it's problem number 29 from this book. Okay, so the purpose of this video is to help you develop your problem solving skills when it comes to mathematics, when it comes to trying to find solutions to non-routine problems. Okay, so the specific problem is not necessarily our main concern, and the specific solution to that problem is not necessarily our main concern. It's how the solution to that problem has developed. Okay, so what I aim to do in these videos is to present my solution to the problem, but really to kind of demonstrate and illustrate to you what kind of ideas I was having as my solution was developing. Rather than just telling you what to do, I'm trying to give you a bit of insight into what kind of thought processes I was going through, what was giving me the kinds of ideas that that I thought were going to work as much as possible. Okay, so I do a lot of private maths tuition for GCSE, IGCSE, and A-level maths, including STEP and MAT. And my tuition really focuses on developing problem-solving skills, because what I find is that those people that get the top grades in their exams are usually the people that have really well-developed problem-solving skills. Okay, not always. Sometimes people can fluke it, but generally speaking, if you want to have confidence going into your maths exams, you need to have some highly developed problem-solving skills. So you need to be able to attack non-routine problems and have suitable strategies for dealing with the kinds of difficulties that you're likely to encounter when it comes to trying to work towards a solution to a non-routine problem. If you're interested in how I can help you develop your problem-solving skills and to help you get the grades, the results that you need to get into college, sixth form, or whichever university you want to go to, please feel free to get in touch. I'd love to have a discussion with you about what your requirements are, what your needs are, and how I can help you. I'd love to see you do the best that you can, reach your true potential, and and secure your place at whichever academic institution it is that you want to go to. So let's have a look at this problem, because it's an interesting little problem. It's not, as with a lot of things when it comes to solving problems in mathematics, once you see what you need to do, things fall into place very quickly. The difficulty is actually finding in the first place what it is that you need to do. And understand that this is a perfectly normal thing when it comes to solving problems in mathematics, that finding that direction, direction that you need to go in, that is going to take you to a good solution to a problem, a correct solution to a problem, that's 95% of the work. Okay, and you've got to work through that. You've got to have the patience and the grit and the determination to actually kind of persevere through that, because if you look at your typical GCSE or A-level maths textbook, what you'll find are fairly routine calculations. There's one or two challenging-ish problems scattered here and there, but generally speaking, they're fairly routine problems. So what you can find is that you kind of develop this impression maybe that you should be able to come up with a solution to a problem within a couple of seconds. Well, that's true for routine problems, but for non-routine problems, which are the genuinely interesting problems that mathematicians like to solve, that's not the case. Okay, it might take you, I don't know, 15 minutes, half an hour, sometimes longer, sometimes a couple of hours, just to find a direction to go in, really. But once you find that direction, you might find that the solution basically writes itself once you've got that clear direction to go in. But there's nothing that you can do to completely avoid this. All you can do is learn to develop certain strategies for dealing with this situation. So that's what I can help with, is helping you with your problem-solving strategies so that you can more successfully attack problems, mathematical problems, and find the solutions that you need so that you're not worrying when it comes to your exams. So you're not worrying as much anyway. Okay, so what we're given for this problem, the information that we're given is that show that b minus 1, so b minus 1 divides the expression b to the power of b minus 2 plus b to the power of b minus 3 plus b plus 1. Okay. Now this is a fairly unusual problem in many respects. Now the natural tendency here, I think, was to go for something like factor theorem. Okay, so if you're doing A-level maths, you're probably familiar with factor theorem. So if this divides this, because you can almost recognize this as a polynomial, but it's actually not a polynomial, you might be tempted to try to plug 1 in here and try to show that you're going to get 0, and therefore b minus 1 divides this. Easy peasy, right? The problem is this ain't no polynomial. This is something different, right? B to the power of b minus 2, that's not a polynomial. Okay? So that strategy doesn't work, unfortunately. Now, sometimes there are clues hidden in the problem. So if it's a well-formulated problem, then you might then things work out nicely. Okay, so we're talking about mathematical problems here, which are of a certain kind. They're not real-world problems, which are messy. Okay, like in physics and engineering and all that sort of stuff. Mathematical problems are of a different kinds. They're elegant. There's an elegance about them. Okay, they're well formulated. Things work out very nicely a lot of the time, and what you can find is that when a problem is formulated, it might not have necessarily been the author's specific intention, but it might be that just because of the nature of that specific problem or the specific set of circumstances surrounding that specific problem, there are actually various clues given to you, subtle clues. Sometimes they're really, really subtle. Sometimes you don't necessarily know how to use those clues. You know that there's a clue there, you don't necessarily know how to use it. There is a big clue here, by the way. It took me a while to pick up on this, but the clue is here in the power. B to the power of b minus 2. Now, isn't that a strange power? B minus 2? Why b minus 2? Why not b? This was one of the things that drew my attention. And I realized eventually that this kind of held the key, really, to making this work. Because if this was b, actually wouldn't work. B minus would not divide the expression, or we couldn't guarantee that it would. Okay, so what can we do here? Well, this might seem like an unusual thing to do, but we can subtract 1 from the b to the power of b minus 2. And then we can subtract 1 from the b to the power of b minus 3. And then we're going to get b to the power of b minus 4, subtract 1. And we can keep on going down, all the way down to the b here. So how many 1s have we subtracted here? 1, 2, 3, 4, 5. B minus 2. We subtracted b minus 2 once, so I need to add those back on, right? This is like if I start with the expression x and I subtract 1 from it, then I really need to add 1 back on. Otherwise, I change its numerical value. So here I'm adding 0 in a very specific way. This is a really common trick, by the way, when it comes to mathematics, to add 0 in a very specific way. So I need to add b minus 2 back on, but don't forget about this plus 1 here, because what happens then is all of this, well, sorry, the b minus 2 plus 1 here just becomes b minus 1. And what do we see then? We see that b minus 1 is a factor of this expression, okay? Because b minus 1 times, let's say, b minus 3, what would it be? B to the power of b minus 4 all the way down to 1. If I expand this out now, what will I get? I'll get b to the power of b minus 2 plus b to the power of b minus 3 plus all the way down to b minus b to the power of b minus 3 minus b to the power of b minus 4 minus all the way down to minus 1. That will cancel with that all the way down. This b will cancel with the b there, and what I'll be left with is b to the power of b minus 2 minus 1. So this works for all of these. For all of these, I can extract a factor, effectively, of b minus 1. So b minus 1 times something plus b minus 1 times something plus b minus 1 times something plus b minus 1 plus b minus 1. So b minus 1 definitely divides each of these. So then I can take b minus 1 out as a common factor of the whole thing. So I'm going to get some crazy expression in here. But very importantly, I've got the b minus 1 here, and therefore this expression, which is equivalent to this, is divisible by b minus 1. Okay? How did I come up with that? I don't know. It's just a stroke of luck, to be honest with you. That's how problem solving works. A lot of the time, it's really just you get lucky. Okay? You just have a stroke of luck. Something occurs to you. Try it. It's a really important aspect when it comes to trying to solve problems is just listen to your intuition. Listen to your gut feelings. Be prepared to try things out. Sometimes they will seem really, really weird, some of the things that you try out. But sometimes they work, okay? And understand that problem solving it's not a purely logical exercise, okay? There is a lot of intuition involved. There's a lot of educated guesswork involved, and sometimes there is a lot of guesswork just out of sheer exasperation, when you've just exhausted all of the other possibilities that you think are going to work, and you just think, well, I'm going to have a punt on this, and it happens to work. And where the idea came from is no result of logic, cold hard logic. It's just a purely intuitive gut feeling that you had, that it was worth a try. Okay, so don't feel that everything that you do when it comes to actually finding a solution to a problem has to come about in a purely logical way. Now, obviously, that doesn't mean that your solution doesn't have to follow sound logic. Your solution has to be logically coherent, and it has to be strict, right? But nevertheless, how that solution comes about is an entirely different thing. And it's very messy and much more intuitive. And just embrace that. Okay, we're not done yet, by the way, with this. So there's another part, which is, and by the way, I'm not aiming to give model solutions here. I'm really aiming to just give an idea about the solution in some cases, because the emphasis is really on how that solution came about. Okay, exploring the motivations for certain ideas and things like that, and just exploring the problem solving process in all its messiness. What I hope to do really is to show you, to a certain extent, how certain techniques can be used in ways that maybe you've not seen before, or maybe you're not familiar with. Introduce you to some new ideas, so that maybe I do something in a solution and you think, oh, I've never seen that before. I've never seen that done like that. I didn't know you could do that. And that might give you some ideas about how you might be able to incorporate that technique into your own problem solving. Okay, I used to love doing this, particularly when I was doing my A-levels, really watching my teachers when they were solving problems, watching carefully what they did, because sometimes they did some really interesting things that I'd never seen before, and I thought, and it was kind of exciting for me, because then I thought, I can put that into my solution. I can start to use that idea in trying to solve problems. And I was looking for opportunities to use that technique in my problems. It was really exciting. So let's have a look at the next part. Thus show that b squared minus 2b plus 1 divides b to the power of b minus, let me get this right, b to the power of b minus 1 minus 1. Okay, so this is kind of a hence. So if you're used to doing A-level maths, then you'll have come across the hence or otherwise phrase. Always, if you're in an exam, go for the hence, by the way. If you're not in an exam, do the hence and then have a look at the otherwise as well, see if you can find something else that's going to work. But we're given a clue here, basically. Thus show that b squared minus 2b plus 1 divides this. Okay, well, it's fairly straightforward based on what we've just done to figure out that b to the power of b minus 1 minus 1, let me write it a bit better than that, is equal to b minus 1 times b to the power of b minus 2 plus b to the power of b minus 3 plus all the way down to 1. If you expand all of this out, then you get this. Okay, so what we can see is that b minus 1 divides this. Okay, who cares? Well, we can also see that b squared minus 2b plus 1 is equal to b minus 1 squared. Okay, b minus 1 squared. If you missed that, then, well, better get to Specsavers. Right, so, but what we've already proved is that b minus 1 divides this thing, right? We've already shown that. So in other words, we've got that, I should have left a bit more space here, so I'll just do this. B to the power of b minus 1 minus 1 is equal to b minus 1 squared times something, and therefore b squared minus 2b plus 1, which is equal to b minus 1 squared, divides b to the power of b minus 1 minus 1. Okay, really dead easy. Nice little problem though. Sometimes these little problems like this are sometimes the most interesting, because they really, sometimes you've really got to think very carefully in order to get the solution. So don't necessarily think that a short problem like this is necessarily an uninteresting problem. That's not the case at all. I found this a nice little problem. So, okay, that brings us to the end of this problem, and it brings us to the end of this video. So if you made it this far, congratulations, but thank you for watching. Cheers.